Hello, I am Seokju Choi in Physics 2212, and this is my lab report for Lab 1 charge tapes. In this lab, we learned that ordinary household objects can acquire excess charge when it is touched, rubbed, or pulled apart. We used charged strips of tape for this experiment and observed their interactions, calculated the excess charge on the tape, and lastly, the forces were visualized using glow script. For experimental preparation, I made two U-tapes, which are 20 centimeter long strips of tape that was both charged by rubbing and pulling apart the U-tape from the base tape. I could tell that the U-tapes were charged since it was attracted to my hand as in the video on the slide. To determine the signs of excess charge, I have interacted these U-tapes with neutral objects, negatively charged objects, and the U-tapes itself. The U-tapes repelled each other and it was attracted by the negatively charged plastic pen, so I could tell that they were both positively charged. For the actual experiment, I placed one of the U-tapes, tape B, on top of two thick books as in the diagram shown, and measured the distance between tape B and the bottom tape, tape A, when tape B started to float. For simplification, I assumed that each U-tape has the same net charge and treated each tape as a single point charge in the center of the tape. The free body diagram for the floating tape B is shown on the right, where FE and FG has to have the same equal magnitude when tape B starts to float. I will call the distance between tape A and tape B as D. These are the measurements and calculations for the experiment. The length of the tape was 0.2 meters each, mass was 0.2 grams, and after 3 trials of experiment, the average distance between two tapes was 0.0163 meters. Using the equations for electric force and gravitational force and setting them equal to each other as the calculations I have written on the right, I could derive the excess charge on the tape, which was 7.61 times 10 to the negative 9 coulombs. Since the deficient number of electrons on the tape can be calculated by dividing the charge of tape B by charge of a proton, it is calculated to be 4.76 times 10 to the 10. To calculate the fraction of atoms that gave up electrons, I have calculated the number of atoms on the sticky surface of tape using the area of the tape and atom length scale, and then divided the deficient electrons by the number of atoms on the surface, which turned out to be 1.32 times 10 to the negative 7. For this calculation, I had to assume that each atom gave up no more than 1 electrons and each atom had the same diameter and never overlapped. In conclusion, I could calculate the charge of tape B, excess electrons on tape B, fraction of atoms that gave up electrons, magnitude of Fg and Fe on tape B, and the results are shown in this page. I have also attached the visualization of two tape point charges and the forces acting on the top tape using glow script. These are the glow script codes that I have written for the calculation and visualization. By glow script coding, I could find out the magnitude of the charge on one piece of tape, which turned out to be 7.61 times 10 to the negative 9 coulombs. I had to ignore air resistance and treat the tape as a concentrated point charge in the center and assume that each U-tape had the same amount of charge. If the electrons had positive charge and protons had negative charge, the tape's charges would have been negative, but the interactions with other objects would be the same since the charges of other objects would have changed as well. Also, it is important to handle the charged tapes as little as possible since when tapes touches my hand or other objects, electrons can transfer to or from the tape and change the charge. This is the end of my lab report, and thank you for listening.